All right, today's lesson is 3.2. We're going to talk about two triangles, and we're going to compare two triangles, and we're going to be able to determine if they are congruent or not congruent. I apologize in advance that the video is kind of grainy looking. It's not your eyes, it's that I had to scan this document in, and so that's why it's a little bit grainy. So just do your best as we go through these notes, okay? So we would say that two triangles are congruent. Remember, congruent means same shape, same size. So we will say same shape and same size. So we would say that two triangles are congruent if all three pairs of corresponding angles, right, there's three pairs of angles, and three pairs of sides are congruent. So if three pairs of angles are congruent and three pairs of sides are congruent between the two triangles, then that means that the triangles are congruent. If the two triangles are congruent, we can write what is called a congruency statement. Congruency statement. When we are writing a congruency statement, order does matter. So when you're writing like triangle ABC is congruent to triangle DEF, you have to make sure that you pay attention to the order. All right, and so we'll talk about what that looks like. So this first example says, draw a diagram that accurately describes the following statement. Triangle ABC is congruent to triangle DEF. So the first thing we need is two triangles. So let's draw triangle A, B, C. And let's match it over here with triangle D, E, F. Now, how do you know which angles match up with which? Well, looking at the congruency statement, it's really helpful. So notice that A is the first letter that they gave me, and D is the first letter that they gave me. That means that A is congruent to D. So angle A is congruent to angle D. Notice the middle letter in the first group triangle is B, and the middle letter in the second group is E. That means angle B, which we're going to mark with two arcs because we've already used one arc, is congruent to angle E. And if we notice again, back up in our congruency statement, angle C is the last letter and angle F is the last letter. That means that angle C, that we're going to mark with three arcs now because we've already used 1 and 2, is also 3. So it says name the corresponding congruent angles. So that means angle A, we said, was congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. So these would be corresponding. Corresponding means A goes with which letter, B goes with which one. So now if we're going to name corresponding congruent sides, again, I'm not even going to look at my diagram because, guys, often your diagram is going to look confusing. The triangles are not going to look like they're the same, and they're going to be flipped around, and it's going to be hard to determine that. So that's why I always like to use the congruency statement. So let's look at our congruency statement again. Now we're going to talk about sides. AB is the first side, so it's the first two letters, and DE are the first two letters over here. So that means side AB matches up with side DE. So let's write that. Segment AB is congruent to segment DE. Okay, let's go back to our congruency statement. The second two letters that I have are BC. And so the second two letters over here are EF. That means that side BC, and we're going to mark with 2 hash marks because we've already used 1. Segment BC matches up with segment EF. So we're going to say BC is congruent to EF. So we have 2 pairs of sides now. If we go back to our congruency statement, we've done the first 2, the second 2, and now to get the third pair we do the first and the last. So that's AC and the first and the last and DF. That means side AC, which we'll mark with 3 hash marks because we've already used 1 and 2. Side AC goes with side DF. So side AC is congruent to side DF. So if you look at this, I have 3 pairs of angles and I have 3 pairs of sides. This would mean that these 2 triangles, ABC and DEF, are congruent. Again, using this the congruency statement is really, really helpful. There are going to be times where you don't have the congruency statement yet, and you'll have to create one, but we'll help you with that. Okay? Alright, so this is kind of a basic introduction of what congruent triangles are. So let's go a little bit deeper. So let's look at some practice problems here. It says, complete each congruency statement by naming the corresponding angle or side. So we have this congruency statement here. I have a diagram, and this is what I'm looking to fulfill. Segment GH goes with which one? If you are purely looking at the diagram, you might be able to make a good guess, but we are not all about guessing. We want to be sure. So let's go back to the congruency statement and not the diagram. We are looking for segment GH, and GH is the second 2. It's the second and third. So over here in this triangle FVU, it corresponds with VU. Would you guys agree with that? So the first 2 the second and third GH go with the second and third VU. So that means that GH is congruent to UV or VU. It doesn't matter whether you say VU or UV, it's the same thing. So all we had to do here was just find the missing piece that they were looking at. So please make sure on your homework that you read their questions carefully about what they're asking you to do. They didn't ask me to mark everything up, they just said find what goes with GH. Okay, so look, if we look at number 2, it gives me the congruency statement and then it says tell me which angle goes with angle E. Now again, if you're just looking at this picture, it appears as though multiple angles could go with E, right? And the diagram is flipped upside down, so this is a time where you can't depend on the diagram. So instead we're going to depend on the congruency statement. E is the middle letter here, which means it corresponds with U, the middle letter here. So angle E is congruent to angle U. But you wouldn't have known that if you just guessed and looked at the diagram. Again, that's why it's critical that you look at the congruency statement, okay? So example 3 and 4 says to mark the angles and the sides of each pair of triangles to indicate that they are congruent. So now they're giving me the congruency statement and they want me to mark everything up. Okay, so let's look at this. Let's start with our angles first. I know that angle E goes with angle E. Alright, well they're both in the middle, so I'm going to go ahead and mark them congruent. Angle E goes with angle E. Then it says angle D, which is the middle one, goes with angle K. So we're going to use 2 hash marks, remember. Angle D goes with angle K. And then last but not least, by default, I suppose, angle C, 3 hash marks, oops, goes with angle L. So we did our angles. So now let's do our segments. So we're looking at the first two, ED. So ED goes with EK. The first two goes with the first two. So ED is 1 hash mark, goes with EK, that's a second, or another single hash mark. Alright, now let's look at the second two. So then I'm going to have DC, and DC is going to go with KL. DC is going to go with KL. And then last but not least, remember, is the first and the last, so EC goes with EL. This would be fully marked. Okay? Why don't you try number 4 on your own? I'll mark things up, but I want you to mark them as well. Go in order, do your angles first. 1 arc, then 2 arcs, then 3 arcs. If you need help, you can look up here. Okay, so before you get going on the sides, please check to make sure your angles all match up correctly. You should have S going with U, R going with W, and Q going with Q. Once you have that correct, let's go ahead and mark up our sides. Okay, take a check. SR should be matched up with UW. They should have the same number of hash marks. It doesn't matter if you start with 1 hash mark or 2, whatever you start with, they just need to be the same. Like SR and UW need to have the same number of hash marks. RQ and WQ need to have the same number of hash marks. And then SQ and UQ. Alright, so pretty straightforward. Now let's talk about what is enough information. Do you really have to find all 6 of these things, all 3 pairs of angles and all 3 pairs of sides every single time? That seems like a lot of work to have to figure out and do. So let's see if there is another way we can say that triangles are congruent by just, oh, I forgot we have 2 more examples. So we're going to see if we can find out some other ways to prove that triangles are congruent without all 6 things. Before we do that, we're going to use this as an example. It says, write a statement that indicates that the triangles in each pair are congruent. Okay, so we're going to start and write our own congruency statements. I like to start with the angles. I think that's easiest. So I'm going to start with 1 arc, go down to the 2 arcs, and then over to the 3. So that means I'm starting with triangle XWV is congruent, and I'm going to look at the other triangle now. So I started with 1 arc, so that means I'm going to start with X, and then I went to 2 arcs, which was W, and then out to 3 arcs, which is, I believe that's an I. Okay, so XWV is congruent to XWI. All right, so why don't you start number 6. If I say, no, don't go ahead yet because I'm going to kind of say this out of order. If I say triangle ZXY, I want you to match that. If I say triangle ZXY, what are you going to say? Please don't say it out loud. Write it on your paper. Okay, so I started with 2 arcs over here. So that means I'm going to start with J. And then I went to X, which was 3 arcs. And so that should be I. And finishing with 1 arc with Y. Finish with 1 arc, which is K. J, I, K. So again, it doesn't matter what order you start in with the first triangle. It's just that the second one has to follow the order that the first one is going in. Okay? Alright, now we'll get to some better usage of finding whether 2 triangles are congruent. It says having to find all 6 corresponding parts can sometimes take a long time with many steps. Instead, there are a few easier ways, or a few congruent theorems that will allow us to find only 3 corresponding parts. It says look for reflexive segments and angles, as well as vertical angles. So we have yet to talk about what reflexive segments are. So a reflexive segment is an example where they share, let's write this down, a reflexive means that they either share a side or an angle. They share it, and we'll look at what that means in just a minute. And then you know what vertical angles are. Remember, they're the X that we have to look for, vertical angles. So we are allowed to use something called side, side, side. If we can prove that all 3 pairs of sides are the same, then we don't have to know anything about the angles, and we can just say that these 2 triangles are congruent by side, side, side. So we're going to use 3 S's, side, 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 to represent that the 2 triangles are congruent. So let's look up here. I have this top triangle, and then I have this bottom triangle. These hash marks are kind of hard to see, so I'm going to darken them in. Okay, so it's giving me that I already have 2 sides that are the same. Would you agree that this down the middle, EC, they share, right? If I were to pull the 2 triangles apart, they would share this side. It's the same side as EC on both of them. That's what we would call the reflexive segment. So because that's a reflexive segment, I'm allowed to mark it. Okay, so in order for me to know that this is side, 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 I would have to know that EC is congruent to EC. That would give me a second side. Again, if I want all 3 sides to be the same, all 3 sides to match up, then I would have to say the third side that I would need to be congruent, but it's not, and I can't mark it if I don't know it. But I would need to match up EU with DC. So if EU and DC were congruent, then these 2 triangles would be congruent by side, side, side. In your homework, it will ask you this question: what more do you need to know? If it is a reflexive segment, you can mark it. If not, you cannot just mark things congruent, and students will try to do that in the homework. You cannot just mark things congruent just because you think that they are, right? In this example, I don't know anything about EU and DC. I don't know anything about these 2 sides. I'm telling you that if you want side, 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 you have to make those 2 sides to be the same, but I don't know that for sure. But what I do know for sure is that this middle segment, this reflexive segment, EC, is congruent to itself. So to be able to prove that this is side, 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 I would need to say that EC is congruent to EC and EU is congruent to DC. That would give me side, side, side. Okay? Okay, let's look at the second way that we could prove triangles are congruent. We have what's called side, angle, side. We're going to use SAS, side, angle, side. Notice with side, angle, side, the angle is included, meaning the angle is between. So if it was side, angle, side, it might look something like this. This angle, this side, this side. Do you see how the angle is in between the two sides? That would be side, angle, side. All right? So in this example, it says, what else do we need to prove? What else would we need to know to be able to prove that these two triangles are congruent by side, angle, side? So if we look at this first example, I have one side that's already congruent. Is there anything that we know to be true that's congruent that is not already marked? Remember up there it says to look for vertical angles. I have a pair of vertical angles here, right? So I'm going to go ahead and mark these. I'm allowed to mark them. These vertical angles you are allowed to mark. So I would need to say, if I want these triangles to be congruent, I would need to say angle DEF needs to be congruent to angle XEV. That would give me the angle. I already have one side. Now, which other side in each triangle would I have to make congruent to be side, angle, side? So let's just look at this top triangle. Here's my side. Here's my angle. If I choose this side right here, would you agree that the angle is in between the two sides, right? The angle is included, the angle is in between. That's what I want for side, angle, side. If we chose this side over here, isn't X the included angle? X is the angle that's in between them, but that's not the one that I have marked. I've marked angle E to be congruent, which means that I need EV to be one of the congruent sides. So I need EV to be congruent to, which side over here in the other triangle do we need to be congruent? So that we get side, angle, side. It would have to be EF, right? If I mark EF congruent, then you can see that the angle is in between the two sides. So I would need EF to be congruent. Okay? Let's look at the second example. I'm sorry, and then it said to write a triangle congruency statement. We've been forgetting to do that. Okay, so if I know that these two things are true, then I can say that it's side, angle, side. So let's write triangle DEF. So if I say triangle DEF, how would you finish that? Triangle DEF. You kind of started outside with D, and then you went past the first hash mark, down past the second hash mark. So how would we do that on the other one? Go past the first hash mark, so that was X to E, then out to V. So that would be X, E, V. All right, let's look at this next example. If I want to prove this by side, angle, side, I already have an angle that's marked on each of them, and I already have a side marked. So if I want side, angle, side, think about what other side needs to be marked so that you can have the angle in between them. I would say on the first triangle it would be XW, right? That would put the angle in between the two sides. And over in the second triangle I would pick GF, because then that would make my angle in between the two sides. Okay, so it says what additional information? We would need to know that XW is congruent to GF. And if that is the case, then these two would be congruent by side angle side. So this time I'm going to write the the congruency statement as VWX is congruent to what? I want you to tell me. If I said VWX, what would you say? VWX. So I started here and I went past the 2 hash marks to the 1 hash mark. So I'm going to go start and go past the 2 hash marks. So I started at E and then go past 1 hash mark. So E, F, G would be correct. E, F, G. Don't forget your triangle symbols, please. Alright, let's look at our last example to prove that 2 triangles are congruent. Oh, it's late, sorry. It's almost 11:30 at night when I'm recording this. We have 2 more to go. I apologize. So next we have angle, side angle. And angle, side angle is very similar to side angle, side. So let's look at this. Angle, side angle. Except this time, the side has to be squished in between the 2 angles. Okay? So let's look at this example. Again, it's kind of light if you can't see it. So it's asking which side needs to be in between. So we've already had the 2 groups of angles that are marked congruent. So if we look at the side that is in between or included, would you agree that DE is in between the 2 angles? All right, so that would be angle, side, angle. That would give me angle, side, angle. And if I look over here in this one, it would be this side. This side gives me angle, side, angle. So I would need to mark the 2 segments that we marked would be segment ED congruent with segment AB. That would give me angle, side, angle. An angle, side, angle, then I would be able to mark or write my congruency statement. So I'll write the first one. If I said triangle EDF, what would you say to that? Write it down, don't say it. If I said triangle EDF, think about what I did. I went from 2 arcs on E to 1 arc on D to nothing on F. EDF, you should say triangle BAC. Alright, let's look at this next example. If I want angle, side, angle, and I already have 1 side marked, I don't really have any options as far as which should I choose because there's only 1 pair that's going to work for angle, side, angle. If I already have this side marked here, then that's the side that needs to be between the 2 angles. And this side is only between Q and the vertical angle QKX, right? Likewise, up on the top triangle, if this is my side that's congruent, it has to be between J and K. Now I know that the 2 middle ones are congruent because they are, again, you guys see it, vertical angles. So for the sake of time, we're going to name this angle 1, and this is angle 2. That's a shortcut. So we're going to say angle 1 is congruent to angle 2. If you're going to tell me angle 1 and angle 2, you have to actually draw angle 1 and angle 2 in your diagram. You need to put a 1 there, you need to put a 2 there, so that I know. Okay, and then angle J is congruent to angle Q. Alright? And if I said triangle I don't have an I, just kidding. If I said triangle JKL, you would say triangle what? If I said triangle JKL, I started with one arc to two arcs to nothing. So you would say QKS. All right, we'll do a lot of practice with these, so don't panic, don't freak out. You're going to be just fine. Okay. All right, let's look at the fourth type. The fourth type that we're going to use is angle, angle, side, and this may be the hardest one to try to find. Okay, so angle, angle, side. We use angle, angle, side. Angle, angle, side means the side needs to be on the end, so it should kind of look something like this. If I'm talking about angle, angle, side, then I would do angle, angle, side. The side should not be between the two angles. It should be out on the edge somewhere. Okay, so let's look at this example. I have these two sides that are congruent. I know that I have vertical angles, so I'm going to mark those congruent. And now my choice is, which angle do I mark? So let's just take one triangle at a time. Let's take the top one, RCP. If I mark this angle R, would you agree that the side is now between the angles? And I don't want the side between the two angles. I want the other angle. So really, the angle that I need to mark has to be angle P, because then that means that the side is not in between them. Likewise, let's look down here at the other triangle. If I mark if I mark angle B, this side CB is now between my two angles, and I don't want the side between the two angles. So instead, I'm going to mark this angle out here. So we know the vertical angles are always congruent, which means that the additional information I would need is that angle P is congruent to angle D. And then my congruency statement would be, let's do triangle RCP is congruent to triangle what? Remember, it doesn't matter how you start, it matters how you finish. Isn't that the story of life, huh? Okay, so triangle RCP. So I started at angle R, which has nothing. So I'm going to start with angle B that has nothing on it. I went down to C, which matches because they're vertical angles, and then out to two arcs. So it should be triangle BCD. Okay, this last example. If I want this to be true by angle, angle, side, if I mark angle B, would you agree that that would satisfy angle, angle, side, because the side that's between the two is not marked? So angle B would work here. Let's look at this though. What if I said angle C? Is the side between them marked? Nope. So this would also be angle, angle, side. So in this example, you could use either angle B or angle C to represent angle, angle, side. It doesn't matter to me which one. So let's use angle C, and I think the one that's going to correspond with that is going to be angle Q. So the additional information that we would need is that angle C is congruent to angle Q. So then if we're going to write our triangle congruency statement, if I said triangle ACB is congruent to triangle, you would say what? Write it on your paper, don't shout it, please. ACB is congruent to SQR. Good. Okay, once you prove that your triangles are congruent, the leftover pieces that were not marked are also going to be congruent. So once you've proved your three things, the leftover pieces are also congruent. We call this, hang on tight, we call this CPCTC. CPCTC. That means that corresponding parts of congruent triangles are congruent. For example, let's go back to side, angle, side. Mark a side, remember the angle in between them. If I know that these three are congruent, two pairs of sides and one pair of angles, that means that the rest of the diagram should match up. This side would be the same as this side, this angle would match this angle, and this angle would match this angle. That's what CPCTC means. If you prove your three things are congruent first, then everything else matches up. That's what CPCTC means. It's fancy words for saying everything else matches up. Okay? So let's review really quickly. We have 4 ways to prove that triangles are congruent. We said we have, the first one is side, 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 right? Let's draw a quick picture. One side, two sides, three sides have to match up. Then we have side, angle, side. Again, we're doing this with 2 triangles, but for this example, we're just going to use one so that you can see. The angle, remember, has to be in the middle for side, angle, side. The third way, was angle, side, angle. So angle, side, angle. And remember, the side has to be in the middle between the 2 angles. The fourth way is angle, angle, side, where 2 angles and then a side that's not in between would be congruent. These are the only 4 ways that we've talked about. Some of you might try to do this, angle, side, side. And if we do angle, side, side, this is not a word that we are going to use in our classroom. Okay, really, there's a geometric reason, a theorem, and a reason behind why this doesn't work. But for time's sake, just know that we don't say ass in our class, so we're not going to use this as an example. The only time angle, side, side would work is if you have a right triangle. So let's draw a right triangle. If you have an angle and you have this side, which is called the hypotenuse, we haven't talked about this yet. This is chapter 5. If you have a hypotenuse and then one of the other sides, this does look like angle, side, side, but because it's a right angle, we use, instead of angle, side, side, we use what's called HL for hypotenuse leg. And you do have a couple in your homework that are hypotenuse leg, but again, you can only use it if you see a right angle. So only use if right angle. If you don't see a right angle, do not use don't use ASS ever, but only use ASS as hypotenuse leg, HL, if you see a right angle, okay? But these 4 over here are what you're mainly going to focus on. Hypotenuse leg is rare. We don't use it a lot, but I think there are a couple in your homework that are hypotenuse leg, but never ASS, okay? Good luck with your homework. Do your best that you can. Please make sure the directions change rapidly. So please make sure that you are reading the directions carefully and asking questions if you don't understand the directions, okay? You may write on lesson 3.2 because there's way too many diagrams for you to have to redraw them. So you may write on lesson 3.2, okay? Good luck.